Hi, my budding learners. So, once again, you are back with me at your own learning platform, Learn Forward. And we are here with your maths book from Feather Caps. Today, we are going to start a new chapter, very interesting, and that is chapter 6 of your book, in which we'll be talking about geometry. What is geometry? You have learned about many shapes. You have learned about lines, line segments, rays, point, isn't it? All this is a part of geometry. So maths is vast enough and geometry is a segment of maths. So let's first recall what you remember from your past learning. Here we have a gear up exercise for you children. Look at the word math. Can you see? M A T H. So these are the letters of the word math which are made using some lines, line segments and rays. So what you have to do? You have to identify these lines, line segments and rays in each of the letters of math and name them. So when you look at M, what do you see? There is a ray here, there is another ray here. So we write here ray, and rather than writing, we have another way. I'll tell you both ways. Rays. What are the rays here? BA, DE. Now to avoid writing these rays, you can also write it like BA, make a ray over it. Then DE, make a ray over it. So it means we are talking about ray BA, ray DE. Coming to next, they are talking about, we have line segments here, BC. I'll make line segment over this just to make sure that this is a line segment I'm talking about. Similarly, you have CD. This is also a line segment. Do you have any line here? No. So that's all done. Similarly, you will be doing for A. Now look at T. Do you have any line segment there? No. Do you have a line there? Yes, a line has arrows in both the sides, which means it can be extended non-stop, indefinitely, infinitely in both the directions. So this is KM. And now because this is a line, you will be marking arrows in both the directions. Oh, sorry, this is not for A. This is for T. Right? So your line here is KM. This is your line, draw arrows. And the other one is ray. So it is LN. LN is your ray, it is going in this direction because L is the fixed point. So we make sure that when we write the name of ray, we have to put arrow towards the movement of ray. So it is moving towards N. So we are starting from L, LN, and then we put the mark of ray here. So same way you can do for H also. Now let's understand about angles. What are angles? When you have two rays starting and going apart from the same fixed point, two rays rising from the same point, fixed point, starting point, that gives you an angle. And what is angle? It shows how much apart are those two rays which are starting from the same point, right? So this is what we have in an angle. This is your fixed point O. This is one ray and this is another ray. So what you see, these two rays are starting from the same common point O. Now we call this as an angle. What are the different parts of this angle? Let us understand. This fixed point is called the vertex. What is it called? Vertex. V-E-R-T-E-X, vertex. The two rays are called the arms of your angle. They are just like your two arms, children. So these two are the arms of the angle. This point is fixed. This is called the vertex of the angle. And how do you write the name of this angle? Each ray has a name. This ray is OA, this ray is OB. Now, there are three ways of writing the name of this angle. First way is angle, start from A, angle AOB. So, this is how you write angle. We say this as angle AOB. The other way is just reverse. We start from B, we say angle BOA. So, another name is BOA, which also means we are talking of the same angle. The third way is just write the vertex. So, we say angle O. This is another way of writing the name of this angle, right? So, what we have learned till now, vertex is the fixed point from where both the rays start. Then you have the two arms of the angle, and then you have learned to name the angle in three different ways, AOB or BOA, and the easiest is just mention the vertex. So, that is called angle O, right? Now, the next very important thing is how do you measure angles? You have learnt about measuring line segments, isn't it? So, using that you can tell what is the side of different polygons, the square, the rectangle, or any shape that you have. So, can you measure the side of a circle using your ruler? No, you cannot. So, this is the importance I wanted to explain you of measuring. Similarly, here also in angles we can measure. But then how can you measure how much apart are they? Is it by using a ruler again? No, children. Here we measure using a different tool, mathematical tool, geometrical tool, that is called protractor. And this is something it looks like. This is like a half D or a half moon in the sky. This is called protractor, right? Now, do you see some numbers are written here? Yes. So, let me first introduce you to the different parts of this protractor. This protractor is a geometrical tool which helps you in measuring the angles, and angles are always measured in degrees. Okay. So, how do you measure them? Let's first understand this protractor. This point is called the center of your protractor. What is this called? This is the center of your protractor. Now, there is a line, this line. This is called the baseline of your protractor. Not about this. I am not talking about this. I am talking about the line where you have the center of the protractor. So, this is the marked line, the line that you see here in blue. Some of you might be having protractors with black. So, there everything is written in blank, indicated in black. So, this is the baseline. Now, look carefully at your protractors. What will you find? Some numbers are written like this in a circle, and those numbers are starting from 0 on this side also. Read out up to which number are they going? 180. But as you reach 180 this side, you observe, oh, there is another 0 here. And when you move ahead, you see this is also reaching to 180. These are the two scales of your protractor. Just like in your scale, you have inches on one side, centimeters on other side. Your protractor also has two scales, but the scales are equal. Inches and centimeters are not same, but here these degrees are equal. The only difference is one scale starts from the left side 0 and goes up to 180 on the right side. The other scale starts from right side 0 and goes up to 180 on the left side. Now, why this? Let's understand the significance of these two scales on the protractor. Suppose you have an angle. This is your angle POQ. You want to measure it. Now, how do you mark any angle? We just put a small arc at the vertex. This is called marking an angle. Now, when you have to measure it, what you have to make sure? I have just told you about the baseline of your protractor, and here also your angle has a baseline. This is your baseline. The center of your protractor should be fixed at the vertex of the angle. Now, see here, how do we keep protractor? This is the vertex of the angle O, and what we have done is just look at the protractor and its center. Its center is exactly at the vertex O. And the baseline of your protractor should coincide, it should overlap the baseline of your angle. So your angle, the arm OQ, the arm OQ of your angle is overlapped by the baseline of your protractor. Now, when you have to read which scale to use, that is to be understood very nicely. Whether to start reading from 0 up to here, what do you see? The other arm is at number 130. But when you start reading from here, 0, 10, 20, you see that this arm is just at 50. So, which one is the correct reading, 50 or 130? Now, try to understand that this baseline, wherever it touches 0, it can be on this side. Wherever it touches 0, we'll start reading ahead from 0 on that side. Now, when I have the baseline here, my 0, the bottom 0, the first one, the scale 2 is reading 0 here. So, 0, 10, 20, 30, 40, 50. That means my this angle is 50. But, so this is how my angle is opening, children. You can just see like this. These are my two arms. This has started moving and it has opened just 50 degrees, right? So this is the opening, how my two arms are apart. But if I look at the other side and I have my baseline of the angle here. Now, if I open my other arm of the angle like this, now where is it going? It is going from 0 up to which number? Now it is going up to 130. Why am I reading from 0 this side now? Because my base arm is on this side. So, wherever the base arm of your angle is, you will read 0 from that scale. If it touches your 0 on this side, move reading 0, 10, 20, 50. If it starts from here, you will start reading and you will stop at 130. So, same angle will be measured from which side? It will be measured from the side where the baseline touches 0 of your protractor. Okay. So, this baseline is touching this 0. You will go like this, reading here. Do you see the baseline here? No. That means I will not read from this 0. No. Okay. I hope I have made this clear to you. So, can we move ahead? Now, next is construction of angles using protractor. How do you construct? Suppose the same angle of 50 degrees you have to construct. So, what you will be doing? First, you will be drawing a baseline, any length. So, that will be a ray here, not a line. Just draw a ray, one of the arms of your angle. So, if you have to draw an angle of 65 degree, we take a ray AB. A will be the fixed point here. So, this is your fixed point. What you will do? You will again put the center of your protractor on this. This will be the vertex of your angle. Put the center of your protractor here and then your baseline here should overlap with your ray AB. Now, you have to draw an angle of 65 degrees. So, because this side is your baseline of the angle, so we'll start reading from 0 here. Start from 0, this is 60, this is 70. That means the mark in between 60 and 70 is exactly your 65. So, just put a dot over here, then remove your protractor. And you have 2 points now. One point is A, the other point is C. So, you will join these 2 points and make it a ray. You can extend it as much as you can. So, extend it, give it an arrow to show this is the other arm of your angle, and this is how you get 65 degrees. Now, let's do an exercise. Look at the angles given below and fill in the blanks. Angle, what is this angle? Can you name it? So, CDE. So, this is, you can also say this is angle D. What is the vertex? Vertex is just D. With D, you will not write anything. Here, you have to make a mark of angle to show you are naming the angle. If you don't put that mark, it means you are naming the vertex. And then the two arms are, yes, DE, DC. So similarly, you'll be completing for the other two parts, other two angles. Now measure these angles with a protractor and fill in the blanks. So you just have to write what is the measure of your angle. And I told you that angles are measured in degrees, but how do you write the degree symbol? Here it is 65 degrees. So you write the number 65 and a little higher above this, you write, you put a small circle, a dot. This means it is 65 degrees. Can you see this? This small zero above the number shows that you are measuring this in degrees. So make sure that you put that symbol also for degrees. Now, next is draw angles whose measures are given to you. So it is 30 degrees, 50 degrees, 60 degrees. What you will be doing, as we have done here, first draw the baseline, then put your vertex, then just put your center of the protractor at the vertex. Make sure that the baseline of your protractor and the line you have drawn, arm of the angle you have drawn, they should be overlapping. And this protractor should be fixed, it should not be moving. So once it overlaps, read from 0 up to the degrees you want to draw the angle for. Put a dot like we have put here for C for 60 degrees. Similarly, when you want 30 degrees, just make a point at 30 degrees. For 50 degrees, just make a point at 50 degrees. Okay, and then remove your protractor and join these. You get 30 degrees, 50 degrees, like this you get 65 degrees. So you have to join this point C to the vertex you have taken at the center of the protractor. This is how you'll be drawing all these different angles. The more you draw, the more perfect and accurate and even fast you'll be getting at drawing angles. The focus should be overlapping of the baseline with the arm you have drawn, and then the vertex should also be fixed at the center of the protractor. These are the two things you have to remember. Plus the third most important thing is how to read, from which scale you have to read your angle. Okay. Now Harmeet is measuring angle ABC. He measures it to be 120 degrees. Is he correct? Now see, this is your baseline, this side. So will you be reading 0 from here or from here? You'll be reading 0 from here. So 0, 10, 20, 30, 40, 50, 60. What is it? It's just 60 degrees. Okay. So this is what you have to be very careful when you are reading or drawing angles. Now next is, we have different types of angles. What are those angles? The first angle is zero angle. So the different categories of angles, they depend on their measurement. What is the degree measurement of each angle? If it is 0 degrees, that means the two rays are just overlapping. They have not even started moving apart. So such angles are zero angle, where they are just overlapping. 0 degrees is the measurement. Coming next is acute angle. As the two arms of the angle start moving apart, so after 0 degrees till it reaches 90 degree, all the measurements between 0 degree and 90 degree, they are called acute angles. So acute angles are always this much open. Okay. Acute angle is between 0 and 90. The next category is right angle. Just like for 0 degree, it is exactly 0. For 0 angle, it is 0 degrees. Similarly, for right angle, it is exactly 90 degree, just like you have your L in English letters. So you have L like this and this. When you measure, this is exactly 90 degree. I told you we put a mark for, we mark the angles using an arc. When it is 90 degree, we mark it. We don't mark it using a curve, we mark it like this. So wherever and whenever in angles you see a marking like 7 here, it means they are showing 90 degree angle, which is called a right angle. So after 0 degree and before 90 degree, that means between 0 and 90, there can be numerous angles. All those angles are called acute angles. Before that we have 0 angle, and exactly at 90 we have right angle. Next is obtuse angle. What is obtuse angle? When you go beyond 90. 90 exactly is right angle. After 90 starts the journey of obtuse angles till you reach 180 degrees, a straight angle. So 90 degrees is a right angle, 180 degrees is a straight angle, like a straight line. This, see, this is the vertex, just like you open your book. So what happens? The two parts of the two cover page and the back page, they are flat on the surface. So this is like, one is the cover page, one is the back page, and this is fully open book. So it is 180 degrees. This is a straight angle. And after 90, but up to 180, that means between 90 and 180 degrees, they are called obtuse angles. Moving ahead, we have complete angle, which is just completing the entire circle. Now you'll feel what is the difference between zero angle and complete angle then. So what you have to see, remember, is this is my zero angle where both the rays are overlapping. And I am not marking anything. Why am I not marking the angle? Because they have not even started moving apart. But if the same angle I mark like this is called the marking of the angle. Can you see this? Which shows, this arrow shows it has moved from here back up to the same point. It means turned the whole circle. So that is called a complete angle, which is equal to 360 degrees. Okay. So here you have an exercise. Classify the following angles as acute, obtuse, or right. So acute is between 0 and 90, obtuse is between 90 and 180, and then right is exactly 90 degrees. Okay. So what about 79 degrees? That is acute angle. And what about 91 degrees? That's very close to 90, but it comes in obtuse angles. Perfect. So you can do this. Similarly, you have to do the classification of these measurements. So I'm sure you can do. Now, the hands of the clock also make angles. So two hands of the clock, they make angles. Like, what do you see here? This is exactly 90 degrees, so it is the right angle. What do you see here? It has gone beyond 90. Yes, that is obtuse angle. And what about 6 o'clock exactly? It's giving a straight line, so it is a straight angle. And what about the angle here? Again, this is an acute angle, children. So just looking at the two arms of your clock, just see what is the difference, how much apart they are, and then identify the angle. Now, we have the nets of solids here. Net of a solid means this is a flat surface which can be folded to make a solid shape. Like here, when you talk about net of a cuboid, this is the shape. So when you fold, these two faces will be opposite. That is why they are equal. These two will be opposite. So these are equal. And when you fold the top and bottom, they will be equal. So this is how you make a flat net of a solid shape. Cut it, fold it along the lines, and try making your own solid shape. That is a cuboid here. In case of a cube, because all faces are alike, so you can just make 6 faces like this, cut them, and then you can see you get a solid cube when you fold it. What about net of a cone? A cone when opened is nothing but a circle from which a sector is cut. So just take a circle, cut out a piece out of it, and when you turn, if you want to have a closed cone, you can keep a circle also along with it. And if you want to fix a cap over your head, on your head, then you may not put this, right? So just take a cut out of your circle and then fold it in the shape of a cone. So this is how we can cut a plane surface to make 3D objects. Coming to cylinder now. Cylinder is nothing but a rectangle just folded, and you get this shape. This is called the net of a cylinder. You turn it and make it the shape of a cylinder. Now again, if you want this hollow, leave it. And if you want a closed like a tin or some container, then you need to add 2 circles on the top and bottom also. Just like here, what do you see? This is a rectangle which you will be folding into the surface of your cylinder, and this circle at the top and bottom will cover them as the two lids at the top and bottom. So this is another net of your cylinder, which is a closed cylinder with top and bottom. As an exercise for you, you have to complete the following nets by adding 2 more squares. How many faces are there in a cube? 6. How many do you see here? Just 4. So what you can do? You can make such nets of your own and then see which of the faces are missing and where can you add 2 more squares to complete your net. Here match the solid shapes to their nets. So I'm sure you can do them. Let's check. This is your cone. This is your cuboid. This is your cube. And here you go with your cylinder. So easy. Which of the following nets will fold into a cube? Very important. Just make these nets, fold them and observe yourselves. You will learn a lot from this practically when you just cut these nets and try to fold them, that which face is actually opposite to each other and how should the net be formed. So just make such cutouts, try to fold them and see where you can make a perfect cube. Now, which of the following net will fold into a cylinder? So simple, but still you can try it making your own nets, right? Because here you have at the top, but are you going to fold it with here, going to attach it here? Not possible. Do you have 3 circular faces in a cylinder? No. So this is just a logical thinking, right? Otherwise, in case of your cube, you can make the nets. Here also, if you want, you can make these nets and try folding them. You'll realize. Now, there are different views of solid shapes. So, from which view are you looking at the solid shape? For example, if I have this is a cylinder. So, if you look at this, it looks like a rectangle from your side. If you look at the bottom, it looks like a circle. If you look at the top, it again looks like a circle. So, these are the different views of all solid shapes, whether you are looking from top, from bottom or from the side. So, that shows you different views. How? The cube, from whatever angle you see, whether you have a top view, the front view or the side view, you will find all squares there. When you look at a cuboid, at the top you find a rectangle. Then the front view again is a rectangle and then the side view is also a rectangle. When you look at a sphere, sphere is all round from all sides. So whichever view you take, all will be circles. Coming to cone. At the top, you see only a vertex. This is, it looks like a circle with a dot here. When you look at the front view, it looks like this. And when you look at the side, again, it will be the same here. Sorry, this happens in case of a cone. So these are the shapes which are referred to for cone. Circle with just a dot you will be seeing, a triangle with some curve here from front and even from the side. When you look at cylinder, I have just shown you the representation. So your top view will be a circle, your front view will be a rectangle, and then your side view will also be a rectangle in case of a cylinder. Now these are the observations for cubes. For cube, whichever view you take, it will always be a square, and in case of cuboid, it will always be a rectangle. What about a sphere? Yes, that looked as a circle from all the views. Here's an exercise. Draw the top, front and side views of the given solid shapes. Put right, wrong if the views given for each object are correct. So when you look at this at the top, will it show you a triangle? No, this is not. And is it the front view? Yes, this is the, for this, what is the front view? The front view is not circle. So even this is wrong. What about this? From side, if you look at an ice cube, Will it look like a square? Yes, definitely. So this is correct. When you look at the side view of a car, does it look like this? Yes, it looks the same from the side. So here's chapter at a glance, all in a nutshell what we have learned in geometry today. An angle is formed by two rays starting from the same starting point, and that common point is called the vertex. And the two rays are called the arms of the circle. What do you use to measure the angles? We use a protractor. And what is the unit of measuring angles? It is degrees. 6 types of angles we have learned. First is 0. Then you have acute angles. Then you have right angle. Then you have obtuse angle. And you have complete angle. You have straight angle also after obtuse angle. So these are the 6 angles we have learned. There are 3 different views of solids: top, side and front. So we have learned for different solid shapes and seen the different views. Now here's exercise for you, competency based questions. An angle which measures more than 90 but less than 180, what is it called? Obtuse. Which of the following is greater than 90 degrees? Only this, yes. How many right angles are there on the outside of the figure shown below? On the outside you have to see. So 1 angle, 2, then 3, 4, 5, 6, 7, 8. So total there are 8 angles in the exterior of this shape. Miscellaneous exercise. Which of the following measures 180? So you'll just see where do you get exactly the straight. Do you get that in complete angle, 0 angle, obtuse angle or straight angle? It's straight angle. An acute angle measures dash, then an obtuse angle less than, yes. The angle formed by hour hand and minute hand of the clock when it is 3 p.m. 3 p.m. means one hand at 3, the other at 12. So what shape is it? 90 degrees. Perfect. The angle made by hands of a clock at 90-degree clock is dash angle. That is the right angle, of course. Now you have subjective type questions. Neha had 3 pieces of thread. She arranged them as shown here. She then observed that she has created various angles. So can you see how many angles are right, acute, obtuse and straight angles? When you look at straight angles, 1, 2, just 3 angles are straight angles. When you look at right angles, children, when you look at right angles, 1, then you have 2, 3, then you have 4. These 4 angles are right angles. Similarly, you can find out how many are acute and obtuse angles. So just to identify what you can do, you can label them as center as O, A, B, C, D, E, F, and then name these angles in the categories of right, acute, obtuse and straight angles. A cone is placed on a cube. What would the objects look like when viewed from the top? So when you look at the top, it will look like a square and a circle in between. The 3 views of the object are given. Draw the 3D object. So you get this as the front view, this as the side view. So from here, it looks like this, a thinner one, and then top is a rectangle, right? So it looks something like a gate with a top also. Write your name in capital letters. Identify the angles formed in them as shown alongside. So write your own names and then have this fun activity with all the letters of your name. Identify the different angles there in the letters. Here's an activity for you to form different types of angles by paper folding. So you have square shaped paper on your tables, all of you. So you can just fold them and then make different angles. Like if you fold it horizontally, what do you get? This is your straight angle. When you again fold it, what do you get? This is your 90 degrees. That means the right angle. If you fold it diagonally, you get different angles. These are acute angles and this is 90 degrees. So with these sheets of paper right before you on your tables, you can have lots of fun and just identify the different angles you make by folding these papers. So I hope you enjoyed just knowing about the different shapes, angles and rays and lines, line segments in this. So we'll be coming up with more fun for you ahead. Till then, happy learning, children.